Linear models are the applications of linear graphs and functions. It's when we are given a practical situation and we model it and put it into a form that we can graph, we can visually represent the information that we're working with. What we've got here in example 1 is telephone call rates, and we are interested in graphing them and seeing how the function relates to the information. So what we've got here is Ostcom. They have rates for local calls from private telephones that consist of a quarterly rental fee, $50. That's a flat fee. That's just a one-off fee plus 25 cents for every call. Okay, so you pay $50 every quarter, okay, every quarter of a year, and then in addition to that $50, there's 25 cents for every call. What we need to do is construct a cost function that describes the quarterly telephone bill and sketch the linear graph for this. So the first thing we need to do is assign variables. We're going to let C represent the total charge, and that is the total charge per quarter. We're also going to let N represent the number of calls made. We can work out the function. It's going to be the total charge will be equal to 25 cents or 0.25 times the number of calls made plus the $50 that gets charged per quarter. And what we need to do now, that's a linear function, so we can graph it. We can see our y-intercept is 50 and our gradient is 0.25. So what we need to do is graph that somehow. So we're going to mark in our 50. The next thing to do, it's not very easy to work out the gradient, but we can find another point on the graph. Okay, because it's a straight line, all we need to do is need one other point. So let's say let n equal 100 and then work out what C will be. So C equals 0.25 times 100 plus 50, and calculate that out, and that will come to 75. So we know that when n equals 100, or the number of calls is 100, the charge is $75. So we can mark in a point. It's only a sketch, so we've got marking a point there at 100, mark our scale at 75, and mark in our point at 100 and on the x and 75 on the y axis, and then we can draw a line through those 2 points. However, you'll notice that the scale is not right. So what we can do is just put a break in that y-axis. And we can do that. It just makes it easier for a sketch. Okay, we can see that the lower half doesn't work out. And now we can just draw a line through those. Of course, it has to start at 50 because having less than 0 calls doesn't make sense. For our second example, we have Rent a Chef, who provides food cooked and served by a qualified chef at parties. The company charges a $120 booking fee, and after that, an additional $30 per hour. Meanwhile, we have another company called Grease Lightning, provides fast food served by 2 students at a cost of $65 per hour with no booking fee. The question is, under what conditions would it be cheapest to hire Grease Lightning? Again, let's assign variables for the different parts. So we're going to let C, again, represent the total charge or the total cost. And in this case, we'll let T represent the time. that the company is hired for, and that time will be in hours. And what we need to do is look at forming equations for both Rentachef and also for Greased Lightning. So first of all, let's look at Rentachef. Now we know that the cost is going to be $30 per hour, so it's 30 times the time plus the booking fee of 120. For Greased Lightning, however, there's no booking fee, and so we know that the cost C, or the charge, will be equal to the flat rate of 65 times T. So now we can look at those two and draw the graph of them. Now what we need to do is to work out a scale for the X and Y axes. And so mark in some scales. Now if we sort of work out a little bit ahead of time as to what some of the values are going to be, that helps us to work out the scale. Okay, now I've done some calculations and I know that we can go up to say about 900, and we can say go in increments of 100. We know that our y-intercept for Greased Lightning is at 0, and for Rentachef is at 120, so that's down low, and we just need to work out what to expect the values to be at the higher end. Say we go to 7 hours. If we put that in for both Rentachef and Greased Lightning, then we can know what the values are expected to be. So for Rentachef, we've got C equals 30 times 7 plus 120. When we calculate that out, we end up with 330. We do the same for Greased Lightning. C equals 65 times 7, and calculate that out to 455. So what we can do then is mark in our 2 points. So we've got Rentachef at 120, and then at the 330, draw a line through those 2 points. Of course, it's just a sketch here. And we do the same for our Greased Lightning. We know that it starts at 0 and then goes up to 455. So we can mark that point and draw a line through them both. Now what we can see then is when we look at where those two intersect, okay, then we can see that there's a point where Greased Lightning is cheaper, or a range of hours where Greased Lightning is cheaper and where also Rentachef is cheaper. And according to the sketch there, it looks like it's around about a bit over 3 hours where that difference occurs. Okay. Now we can't, because it's only a sketch, you can't accurately work it out on the graph. So what we need to do is find out the exact distance there, or the exact time. What we need to do is to do that calculation. Now that point of intersection is where the two equations will equal each other, and so that's how we need to work it out. We need to let our equation for Rentachef, 30t plus 20, equal the equation for Greased Lightning of 65t. And so when we make them equal each other, we find that we get an answer of, by solving for t, that Greased Lightning will be cheaper between 0 and around about 3.4 hours.